Hello, everyone, and welcome back to another episode of Advent of Code 2016. We are at a what would you call it? A new thing is happening. A new horizon. We had to split an episode in half. Very exciting. Uh, I don't know. If I were doing this live, I probably wouldn't have split it in half. But since I was recording, it's nice to get these into reasonable sized chunks. Even as it is, the first chunk was a little bit longer than reasonable, but I hadn't realized. So. Okay, so where were we? Well, we had finished part 1, and we were going to start on part 2 of day 7. So we were able to recognize ABBA patterns in text and react according to where those appeared. But we didn't get started yet on recognizing the ABA and BAB patterns that we need to recognize. And I was thinking that the way that we're storing the list, the IP address, that is, as just a list, which implicitly have alternating kinds of things, either supernet or hypernet. The way that we're storing that is not very amenable to doing anything very interesting with, like, all of the all the supernet or all the hypernet addresses. We sort of have this kind of awkward state machine for like going back and forth between how we handle the modes, but if we need to do anything comprehensive, we can't really. And that's a reflection of the poor data structure that we used. There's nothing wrong with lists. Lists are great, but they don't really model. A single list is not a good model for the information that we want about an IP address in this context. And so everything that we do is just more awkward than it needs to be. If we instead had an object or even a tuple containing all the supernets and all the hypernets, it would be quite easy. So how okay, let's start with this question. How would we take a list of what are sort of, I don't want to use the letters A and B, but we have kind of, because it's overloaded at the moment, but we have like our list of IP address parts is kind of like an X and then a Y, an X and then a Y, an X and then a Y, right? How do we group those into a list of X's and a list of Y's? I know what I would do in Clojure. I would partition 2, that is to say, split the list into chunks of 2, and then I'd have an n by 2 matrix, and I would call, well, there's no transpose function built in, but there's something that's just as easy. And then I would have a 2 by n matrix, and I'd be like, hooray, I'm done. And I know in Python how to turn an n by 2 array into a 2 by n array, but I don't know how to partition. And I remember having to do this, like, I did partition 3 in day, like, 2 or 3, the triangles one. And I remember that, like, there was not really a better solution. So I guess I'll just go back and steal that transpose from, like, day 3. Chunks. All right. And we could do this with slices now, I have learned. There's a function called islice that lets, that works with like an iterator and returns an iterator rather than being a list thing that returns lists. However, since we're having to call like split and we have a string anyway, it's like we don't really need to treat this as, and we're about to transpose it, so like we're going to realize it all in memory either way, right? So it's fine. So we'll just implement chunks again. And what we'll write is we have this. And so the first question is, what happens if I write zip? Okay, so here's the idea. We're going to write zip of AB with CD. First of all, does that work on strings? Yes, great. Now what about this? This is, I think, unfortunate. I would like for this to return A, B, or AC, and then the list of like B empty. Is there such a thing in Python? Python transpose lists. Well, let's just search for that and see if it gets us anything interesting. So I found transpose list of lists previously. Okay. But is there something about like uneven lists? Zip longest with fill value. What? It's using some ridiculous. What is 6 in Python? Does import 6 exist? Import 6? What the hell is 6? It's a function, I guess. I don't know why it's called 6. 6.moves? I gotta know what 6 is, man. Python 6 module. 6. Python 2 and 3 compatibility libraries. Very funny. Okay. Hilarious. Well, what? Why is it called moves? Moves. I have searched for moves and I regret it immediately. There's just a lot of stuff and I have no idea what is relevant. Also, oh, documentation for 6. Is that good? Okay. From 6.moves. Oh, I see. Python 3 reorganized the standard library and moved them. So 6.moves is a place to get the stuff that has been moved regardless of where it is. All right. Okay, well, this is a little bit dubious, but so what I want to do is basically in IP parts, I don't even need to filter len anymore because I don't care about empty ones. And indeed, I didn't care about empty ones before either. I don't know why I was so concerned. Would have been fine if there had been empty ones. So let's forget about that now. And return like 6.moves.zip longest of star of chunks of 2 and this thing. So if we do that, what is IP parts of, let's grab one of our inputs, like this one. As a list, please. This looks about right. Yeah, we have TIV whatever. Yeah, looks good. We just need to say, we need to add another thing into our zip longest, which is, where was the thing I found? Fill value. Fill value equals the empty string. And now we get this. Great. So now that we have that, well, okay, first of all, let's class IP pass. There's nothing interesting in here. Can I write ret equals make a new IP thing, and then write ret dot supers ret dot hypers equals this? Like, can you tuple destructure into an object as opposed to into locals? Looks like it. Return ret. oops, instead of a list, IP equals this, IP.supers. Okay, yeah, great. It works as I would have hoped. Lovely. So now IP parts is returning an IP object that and indeed, instead of IP parts, let's call it, since we're now actually like sort of parsing it into a meaningful thing, let's call it parse IP. And we'll call this parse IP. And now we just have to modify. So we could have like left that alone and left accepts TLS alone. But in fact, now that we have a good data structure to model our problem domain, we can really simplify accepts TLS a lot. We can, in fact, make it one line. Amazing. Return any of contains ABBA of IP.supers and not any contains ABBA of IP.hypers. Hello, why are my parents unbalanced, please? Oh, they're not. I'm just so used to Lisp where I would have needed at least one more to close the and. There you go. So that really, really simplifies things, I think. And I considered doing this earlier because it seemed like sort of a better model for the domain, but I didn't see what concrete improvements it was going to have. So I just did it the way of like having alternating lists of things, and I wrote this wild old state machine to go through it. And it made the problem a lot harder. There's a lot more code to debug. It turned out that code was right, but it was not obviously right. I had to inspect it more carefully. So can I like, how do I break this up into a reasonable line? I don't know. Is that still legal? Yeah. All right. And it ended up that like actually modeling the domain well would have led to a simpler solution. So I think that that's a good lesson, is like try to figure out a good data structure that models the things you care about in the domain, and not just the simplest, easiest data structure that like has enough structure that you can get answers that you want. If you pick a data structure that maps well to your domain, things will just be easy that you won't even notice. And if you pick a bad data structure that's like technically good enough, things will be hard and you might not notice. And that can really pay off in the long term. So there you go. That's today's software engineering lesson. As highfalutin as it might be, take my advice with a grain of salt, of course. And choose data structures that fit your language too, right? Like in Clojure, I would have used like a tuple of lists. I wouldn't have used a class, for example. And it would have been pretty easy to have done that. And I think it would be a good, like a tuple of lists is a perfectly fine way to model this. It doesn't have to be a class with two lists in it. They're isomorphic, of course. But in Python, a class is sort of the more natural way to do it. In Clojure, a tuple is like the more natural way to do it. But in either language, a list with values of alternating meanings sort of implicitly encoded into their position is like not a good model. So that's my advice. Don't do that. All right. So now we just have to write a more complicated def accepts SSL super secret listening on an IP. And we can't make this one quite as simple because we can't break it up into contains ABA. But what we can do is there a Python, like, what is Python's version of Mapcat? Is it like, So I want to map a function over a list and concatenate the results. That's what I want to do. And I don't know exactly how that works. It's probably in itertools, who knows. Let's just search for Python mapcat. Someone else has surely had this question, with even those very same words. I see some people have rolled their own, which is a little bit worrying because it tells me it's not built in. Python map concat. How? No, 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 no. I'm sure there's something you can use in in itertools, I guess. Maybe I should bookmark itertools. Jeez. So let's look at itertools here. What do they have? They have chain. So chain is basically apply concat. And so I could use chain of map of whatever. I'm just a little bit puzzled that aha, there's a thing called star map. Wait, what? Is that what I want? No. That's mapping of apply a function, not applying, not calling mapcat on a thing. Here, I'll let you guys have a look at this. So I'm looking at the stuff in itertools. Wait a minute, I didn't. I left you looking at Python. All right, yeah, there we go. Okay, so I'm looking at the stuff in itertools. And the functions I've looked at that are interesting are chain. Chain takes basically a list of lists, if you call it with star anyway, and concatenates them into a single list. So that's fine. We could use chain of star, of map, of whatever, and we would get there. But it's a little bit primitive to do it in pieces like that. I'd kind of like to have a mapcat if there is one. And I saw star map, which made me think, oh, maybe this is it. But actually, it takes a function. It's basically mapping apply f over the sequence if you're used to the Lisp version of apply. And that's not what we want at all. No. Just checking. It's not. Great. How about these? These don't look relevant at all. No. Okay, so it looks like we have to use chain. I guess that's life. So what I want to do is let's define ABAs of a string. To be for a string, return all the ABAs in it. Well, back to this Python. What is it I want to search again? I want to search for find all regex matches. So what does find all do exactly? Does it skip over? It returns all non-overlapping. Is that what I want? No. I think I want them to be allowed to overlap. Because A, B, A, B is an ABA whose first character is A and second character is B, and it's also an ABA starting with B and then A, right? So subs, like, there's not regex search, string pause, end pause. Okay, this isn't exactly the same as slicing, but not okay. Regex match. Full match? Find all. but also accepts positional. Didn't we have that in find all? Pattern string, no, I guess not. Okay. Oops. Wait, what is re.sub? Oh, substitute, of course. Escape, purge, yeah, we didn't care about any of that. Find all, find iter. Huh. So it doesn't look like there's a good way to find overlapping matches, which we do want. Does match require that you match the whole string? Module contents, search, match, starting at the beginning. Yeah, that's the difference between match and full match. Is match starts at the beginning, full match starts at the beginning and ends at the end. Okay. So we kind of have to iterate over the whole string and call match ourselves to find a match, I think. Right? Okay, we do have a enumerate. So I think what we need to do is something like the following. For I and nothing in... Wait, is for in like the way you do things in Python? I've forgotten. I think so, yeah. For I, okay, yeah, all right. In enumerate of s, if let's say x m equals re dot match. It's called match, right? Match r of anything followed by something that's not the same as that one thing, but is a character, and then something that is that first thing. Yeah, let's just put that into. Okay. If m return, not return, yield. Oh, match needs. Wait, how do I pass an offset to that? Do I need an expression object? Search match string. Yeah, okay. So in fact, I have to say ABA pattern, ABA RE equals RE dot compile of this ABA RE dot match of s starting at position I. Now, if m, we need to yield m dot let's see. Actually, nothing dot join of m dot groups. So let's try that. Pass. No, it does not like this. Why am I not? Can I not write this thing here? What's wrong? Return, compile, error, invalid expression. I guess it's mad about my regex? Oh, a backslash appeared there for no obvious reason. Okay, that's exciting. Okay, that's better. So let's try ABAs of A, B, C, D, C, F as a list, please. Nothing. So CDC should have appeared. So we got something wrong again. Oh, the backslash was meant to go here. That's what was wrong. Okay, we found CDC. If we put another D here, we get CDC, DCD. Perfect. So great. That's exactly what we wanted. ABAs is correct. Now what? Now we need to decide whether an IP supports SSL according to this list of ABAs and BABs. So let's write a little function here. Def invert takes an ABA and it's going to return a BAB. And it's real simple. It just takes like return nothing.join. Oh, I've been using single quotes mostly. Of ABA0, ABA, oh, I'm doing it backwards. 1, 0, ABA, that should be a 0, 1. So nothing very exciting, but invert of ABA is nothing. It's broken. Join. Oh. There we go. Returns BAB. As we hoped it would. So now, what about this accepts SSL? What we need to do is write ABAs equals, let's map invert over chain of tools.chain. Oops, can I import iter tools as I? Like, can I do that? Well, we'll find out, I guess. Map invert over iter tools.chain of star of map of ABAs of IP.supers. Let's just return ABAs now and see if we got that at all close to right. Well, it compiled, so I accept. I don't know. Let's try. Let's try accept SSL of parse IP of do I not have any instances of parse IP in here? Here's a string. Oh, we called it IP parts at the time. That's what's wrong. Underscore. Error. ABAs unreferenced. No, referenced before assignment. Oh, this should be. Here. We have okay. So we need a different name for this because we wanted to call ABAs. Super ABAs. We'll call this super ABAs as well. How about this? Map requires at least 2 args. Well, that's a great point. So we wanted a comma there, not parens. Returns HSH, XBX, and GVG. That sounds pretty good. Why, though, does it not return V? Okay, why does it not return VGV? It's right there, is it not? So that's. Oh, why am I see. I'm inverting them because my plan was to immediately search for those. So let's in fact just change the name of this thing. It's not super ABAs. It's Bab searches. Okay, great. So it was doing the right thing. I just forgot what it was supposed to do. And then we just what is bool a function? Bool of list? Yes, returns false. Bool of 1 returns true. Perfect. Return bool of I don't want to make a list just to check if it's empty. I would love to make a generator just to check if it's empty, because that's like lazy. I'm used to doing that. Here's the lazy sequence, see if there's anything in it. But in Python, you can't easily check whether a generator is empty without skipping its elements. And you can make a list and then check if it's empty, but that means you got to make the whole list. Again, it's this like lists and generators are vastly different things, and if you want to use one or the other, you got to do very different things. And like the stuff you can do with each of them is not necessarily so great. I definitely miss having one object that can act like both of them. Well, really, it acts like a list, but like a lazy list. It's great. It's a value. But okay. We can't do it that way. So the Python way to do it would be to have a for loop, basically, I'm sure. For Bab in Bab searches if any Python string contains, I don't need a regular expression for this. In. Really? The in operator. Wow, in does so many different things. It makes me... Ugh. All right, well, there you go. In. If any... But then now I need another lambda. All right, well, forget it. We're taking the lambda. Lambda... lambda x of Bab in x. Is that what I want? Yes. For each thing to search for, we're searching each of the IP segments for it. We could instead iterate first over the IP segments, and then each one of those search for each of the BAB things, but I don't see any particular reason to prefer that. IP.hypers is what we are searching over. We don't need this parent. Return true. Otherwise, return false. So like I wish that this could just be an expression over a lazy sequence of things to do, of search results. But there's a number of reasons that that's just not a very nice way to write it in Python. So I'm writing it in what I hope is the natural Python way to write it. And now what we need to do is save this here. IP equals this. And write SSL, no, TLS equals 0, SSL equals 0. If accepts TLS, keep spelling TSL, don't know why. Don't need this open parent, I've been writing C as well. Accepts TLS of IP, then TLS. If accepts SSL of IP, then SSL equals SSL plus 1, and then we'll print TLS SSL. How does that look? What do you guys think? Global name 6 not defined. That's true. Import 6. What's wrong? Unexpected string or buffer? What? What? In contains ABBA. And accepts TLS. What are you mad about? You were happy enough with this before. We didn't break parse IP, did we? Also, why does it compile okay in Emacs? Those all compile. Let's kill this Python REPL completely. Yes, destroy it. And then metax run Python again. So we're starting from nothing. This still compiles. Accepts TLS. Still compiles. So, why out here? Oh, wait. This is what we're actually calling accepts TLS. Weird, all right. So that makes sense because that's sort of a thing we changed recently. Line 48 accepts TLS of IP. And then line 23, any... Oh, we need lambdas! Again, all right. I called any. So this is like... I guess it felt like I could write it this way because I've been writing Haskell. You know, everything I do wrong in Python, it's because of another language. It's not because I'm bad. In Haskell, you would just write it as like any. Any is not a function, but you would write like any contains ABBA of IP.supers. You call a function just by like writing the function and then its arguments with spaces in between. So really here, I think the problem is just that I wanted spaces. I don't think we actually needed lambdas because it contains ABBA, doesn't take 2 arguments. So I was wrong when I said lambdas. And also I made it sound like I hate lambdas, which I don't. I think lambdas are great. Python syntax doesn't really encourage them. And every time I have to use one, it's like a gigantic pain compared to how I'm used to lambdas, which is like the lightest weight thing in the world. Okay, well, we're doing a little better now. Any takes exactly 1 argument. Incredible. Well, how do you check a predicate in Python? Python predicate list any. How to achieve any with a custom predicate? Someone asks on Stack Overflow. Okay. Well, that's not my favorite thing in the world, but I guess if that's what we got to do. So what they are suggesting is any contains ABBA of super for super in IP.supers. Okay. And this, and not any, contains ABBA of hyper for hyper in IP.hypers. So we have to, like, that's a thing that I don't like very much in Python, is you see all these, like, x for x in whatever if foo, or like foo of x for x in whatever. And it's like all of these I wish they could just be functions. Like you have to write all these for comprehensions when it's like they don't seem to be adding anything to me. Okay, but you know, here we are. Any takes exactly 1 argument. I did it wrong again. I thought any took a lambda. Yes, down here. I called any again. Here actually is a little bit nicer, I think. Any bab in x for x in ip.hyper. So that's not too bad. It's a little bit like there's a lot of ins here, and they mean different things. Like, it's not at all clear to me as a human being how to parse this sentence. I'm sure Python knows what it means. But I don't necessarily. With practice, I probably would. But it's a bit of overloading of in, and it's a lot of, like, just words all in a row with no punctuation between them to help me figure out how to parse it. So, there's that. But anyway, we got an answer. 242. Let's see how we're doing here. Correct? That's the right answer. We did it. Amazing. So day 8 has started, but I haven't solved it yet, so we're going to do that in a future episode. I guess, however, we still have a bit of cleanup left to do. Git add p, and I kind of want, if I could, to remove just this line in a commit before because I realized when I did part 2 that I had left a print in part 1, right? And I'd rather remove that commit from history. Not remove that commit, but change it so that I don't remove this extraneous print in the same commit that I'm doing a bunch of other stuff. What is the best way to do that? I could git stash what I have, reapply that change, commit it, stash pop, and resolve the conflict. That would be it wouldn't be hard, it would be a little bit involved. It seems like there should be a cleaner way. And like there is? Let's try something a little fancy. Git add p. Split, no, edit. Every time I use an interactive hunk editor, I'm like playing with fire. I'm going to make this a little wider here since we're doing something a bit involved and there's nothing left to do in Emacs. So how did this end up looking to you guys? Oh, you can't really see it? All right, how about that? There we go. So what I want to do is write the hunk, the diff that I would like to have written, and commit that without actually changing what's on disk. So what I'm going to do is just leave that as context. Yes, we do want to delete that. We do want to delete. We want to leave that as context, and we don't want to add any of this. So this is the diff that I wish I could commit. And indeed, by the power of interactive hunk editing, I can. I'll say git commit -- amend no edit. And now if I look at my git show, it looks like I wrote it correct the first time without that silly print. So great, that's what I wanted. And now I can git add p. Well, really, I just wanted to get out all of it, but I'm just in the habit of typing git add -p. But I should have reviewed what I'm writing here, see if there's anything silly. But no, this looks fine. Lengthier than I would like. Oh, of course. It's not quite right because we didn't actually remove... Wait, what? Why is print valid being minused? Shouldn't that be gone? There's only one print. Git show. Oh, print valid, of course, is correct. Print valid was what we intended to print. It was this other print that I got that I excised from history. I was just confused because of where the print valid was, but it's exactly, yeah, okay. So this is what we wanted to commit. Fine, git commit -m day 7 part 2. Git push. Okay, and with that, I think we are now actually done with this day's work. So I hope you guys enjoyed. It definitely was a bit more of a challenge. than the previous nights. Even though the algorithms were not exactly complicated, there were a lot of little twists and turns to debug. So that was fun, and I hope you guys enjoyed it as well. Thanks for watching, and I'll see you next time.